All right, welcome back. So now we're going to be looking at, we're going to try and do D and E here. Then the third video we'll wrap up with F, and these notes are at the bottom. So let's get out our map so we know what we're trying to accomplish here. See if I can fit it all on the screen. Oh, look at that, those technical skills. Okay, so what do we always have to start with? The balanced chemical equation. Well, look here, we have a hydrocarbon plus an oxygen. So this is a combustion reaction. To balance a combustion reaction, double the hydrocarbon, then work down the line. So I have 6 carbons. I need 6 carbons. 2 times 8 gives me 16 hydrogens. So I need 8 times 2 to give me 16 there. 8 oxygens plus 12 equals 20. Divided by 2 equals 10. So now that will reduce down 1, 5, 4, 3. Okay, so now we have a balanced chemical equation. I have 50 liters of oxygen, that'd be my loner, and it wants to know how many moles of C38 can be completely burned. C38 is your propane, so this is like burning on a propane grill or something. So I have 50 liters of O2. Oh, sorry, I forgot to show us where we start. So here I'm starting on my given side. Volume of a gas at STP is my liters. And I've got to get 2 moles of C3H8. So I have to go from liters to moles to moles. You always have to cross the line to change from oxygen to C3H8 or propane. So if I start with liters, and this is kind of easy, just showing you where it is. 50 liters of O2. Right here I have my conversion factor. 22.4 liters for every 1 mole. So this is 22.4 liters of O2 equals 1 mole of O2. So now I'm down to moles. How do I go from moles to moles? Well, I use my ratio coefficient. So what's the coefficient for O2? 5 moles of O2. What's the coefficient for C3H8? Because that's where I'm trying to go, is 1 mole of C3H8. The diagonals cancel. Move that across. Let me do the calculator here again. 50 times 1 times 1 equals 50. So multiply the top, we're going to divide by the bottom. 22.4 times 5 equals 112. So then you go 50 divided by 112 equals 0.45 moles of C3H8. So if I have 50 liters of oxygen, I would have to burn at least almost a half a mole. Okay, let's go to this next one, still using liters. Okay, you have to balance the chemical equation again here. So I have 2 LIs, I need 2 LIs. I have 2 oxygens, so I need 2 oxygens there. But now what does that do to my Li? Makes that 4 and 1. So 23 grams of lithium. That's my loner. I'm trying to want to know how many liters of oxygen must be used. So liters of O2. So now I'm going to go from grams. Let me bring this down a little bit so you can see it. I'm going to go from grams, and I've got to end up at liters. So I have to go from grams to moles to moles to liters. So to make that change from grams to moles, the first thing we have to do is find the molar mass of lithium. Well, you look at your periodic table, it's 7. 7 grams of Li equals 1 mole of Li. That gets me right there. Using my ratio of coefficients for moles of Li equals, I'm trying to go to O2, 1 mole of O2. Notice I crossed the line, so I changed my colors because I changed from lithium to oxygen. And now, how do I go from moles to liters? I use that 22.4 liters conversion factor. So I have 1 mole of O2 equals 22.4 liters of O2. That cancels, that cancels, that cancels, that cancels, that cancels. How do you know when you're done? Well, when this unit matches that unit. Okay, now we're going to multiply here. 23 times 22.4 equals 515.2 divided by 7 times 4, which is 28. So now if I go 515.2 divided by 28, that equals 18.4 liters of O2. So if I had 23 grams of lithium and I mixed it with oxygen, and I wanted to mix it with oxygen, I would need 18 liters of oxygen to mix lithium with that much. Okay, so let's pause there and take a break and then we'll finish these up.